Myself, MS Vidya S. Patil, Assistant Professor, Department of Electrical Engineering, Anasaheb Dange College of Engineering and Technology, Asta. So, in the last session, we have seen the points regarding the diode, and in this today's session, we are dealing with the applications of the diode. In that, first, which is a very important application, that is nothing but the rectifier is there. So we will see in detail what is mean by rectification, what is mean by rectifier, and the types of rectifier in detail. So the content of the today's session are rectification, types of rectifier. Basically, types of rectifier consist of the two types, half wave rectifier and full wave rectifier. In full wave rectifier, again it is classified into two types, that are nothing but types of full wave rectifier consist of center tap transformer rectifier and bridge rectifier. Firstly, we will see what is mean by rectifier, what is mean by rectification, and then we will proceed for the types of rectifier. Rectifier is a device which converts alternating voltage or current into direct voltage or current. In short, we called it as a AC to DC converter. And now we will see what is meant by rectification. So rectification is nothing but a process. Okay, so it is a process of converting alternating voltage or current into direct voltage or current. We will see what is the difference between rectifier and rectification. A basic difference between rectifier and rectification is that rectifier is a device and rectification is a process. This is a basic difference between rectifier and rectification. Okay, in one line, in summary, we will say that AC to DC converter is nothing but rectifier is there. Next point is types of rectifier. Here there are two types of rectifier, half wave rectifier and full wave rectifier. So in full wave rectifier, again it is classified as center tap transformer full wave rectifier and full wave bridge rectifier, or also we called it as a bridge rectifier. We will see firstly half wave rectifier. This is nothing but a circuit diagram of the half wave rectifier. In short, we called it as a HWR. Why the name half wave rectifier? We will see firstly. Okay. Why the name half wave rectifier? Because conduction takes place only during one half cycle of the AC supply. Therefore, we called it as a half wave rectifier. We will see in detail related to half wave rectifier. Before that, we will see which are the different components of that half wave rectifier. So, first, single phase 230 volt AC supply has to be provided to the rectifier. After that, a transformer is there. T1 is a transformer which is a step down transformer. After that, a diode is there and a load resistance is there. We will say that a single phase AC supply, transformer, that is step down transformer, diode and resistance are the components required for the construction of half wave rectifier. We will see its operation and working of the half wave rectifier. For that purpose, we require equivalent circuits for the positive half cycle as well as the negative half cycle. Firstly, we will see equivalent circuit for the positive half cycle. Again, same components we have to consider, that is single phase supply, step down transformer T1, diode D and load resistance RL. We will see how it will operate. If we supply a positive half cycle deals with 0 to pi, 0 to pi. So in the positive half cycle, diode D comes in the conduction. Therefore, across the load resistance, we are getting the output. How we will say we are getting the output? For that purpose, consider VAB. VAB is nothing but transformer secondary voltage. So we are getting transformer secondary voltage across the load resistance RL. How we will get? So in the first session, we have seen diode comes in the conduction when external positive supply is connected to anode and external negative supply is connected to cathode. Here we have considered for our simplicity point A and point B. In that also, point A is considered as a positive and point B considered as a negative. Means positive supply is going to the anode of the diode and negative supply is going to the cathode of the diode. Therefore, we will say that diode comes into the conduction. or we will say that diode is in on state. On state is nothing but diode acts as a closed switch. Why? Due to diode comes in the forward bias, means when diode is in forward bias, it acts as a closed switch. If it acts as a closed switch, means a path is there for flowing of the current from point A towards the load side. How actually that load current IL will flow in this particular circuitry, we will see that after getting supply from single phase 230 volt AC supply, it will come up to the point T1. Main function of this transformer T1 is to step down the voltage. After that, supply comes to point A. After that point A, through D, through load resistance, again it comes back to the B. Hence here a half cycle will get completed, or we will say that positive half cycle will get completed. Therefore, across the load resistance we are getting the output. From this positive half cycle, we will conclude that in positive half cycle we are getting output across the load resistance, that is nothing but V0 we are getting. We are proceeding for the negative half cycle. So equivalent circuit for negative half cycle is shown in this particular figure. Again here same components are there. Single phase 230 volt supply is there. Transformer, that is step down transformer, is there. Diode is there. Load resistance is there. Okay. But here a difference is that in the reverse bias, diode doesn't comes in the conduction. Already we have seen this part in the first session. So accordingly, how we will say that diode doesn't comes into the conduction when it is reverse bias? Because we know the concept of reverse bias. When external negative supply is connected to anode and external positive supply is connected to cathode, then diode comes in the reverse bias state. And if diode comes into the reverse bias state, means it doesn't conduct, it acts as a open switch. Here we are seeing that if it acts as an open switch, then there is no any possibility of passing the supply or current from point A towards the load resistance. Therefore, across the load resistance, we are not getting any output. Output is suppressed, or we will say that output is equal to 0 in the negative half cycle. So here we will say that diode is in off state, means it acts as a open switch. Therefore, we are not getting output across the load resistance. With the help of this positive half cycle and negative half cycle, we are able to know which kind of output waveform we are getting. So these are the waveforms of the half wave rectifier. Already we have seen that transformer secondary voltage, that is nothing but VAB, is input we are getting across the point AB. Therefore, VAB, this is nothing but the input waveform VAB. Second waveform is the load voltage, and third waveform is the load current. So we will see waveforms of the half wave rectifier. So first waveform consists of the secondary voltage VAB. Here we have seen the cycles are there. 0 to pi is a positive half cycle, pi to 2 pi negative half cycle, and same cycles repeats. So this is nothing but the secondary voltage VAB, that is nothing but input to the rectifier. Already we have seen in the positive half cycle we are getting output only in one half cycle, and that is one half cycle is nothing but 0 to pi. In the 0 to pi, it is a positive half cycle, and in half wave rectifier we are getting output in the positive half cycle 0 to pi. In the negative half cycle we are not getting the output, that is output V0 is equal to 0, or we will say that output is suppressed. Why? We know that when diode is in reverse bias, it acts as a open switch. Therefore, we are not getting output across the load resistance. Therefore, in the negative half cycle, the output is 0. Means in pi to 2 pi, we are getting the 0 output. In same way, we will see the load current. Here, shape of the load voltage and load current is same, but there is difference in the amplitude. Means here, amplitude of the load current is less as compared to load voltage because of the power dissipation. Okay, so why shape of load voltage and load current is same? due to the resistive load, or we will say that due to purely resistive load, the wave shape of the load voltage and load current is same, but there is difference in the amplitude, means amplitude of load current is less due to the power dissipation. Then this is nothing but the summary points of the half wave rectifier. First one is a diode when it is in forward bias, second one when diode it is in reverse bias. Here first diagram indicate diode is in forward biased state, means after the application of input and operation we are getting output in the positive half cycle only. Therefore here that half cycle is shown, means diode acts as a closed switch, means diode is on, therefore we are getting the output in the forward bias. What about reverse bias? So this is nothing but a second diagram which deals with a diode operation in the reverse bias state. Here diode acts as a open switch. When diode acts as open switch, means diode is off. Therefore, after the application of the input also we are not getting the output. Therefore, output V0 is equal to 0 volt we are getting. Then we will see the points or key points related to that half wave rectifier. So during positive half cycle, already I have told you, in positive half cycle means we are dealing with 0 to pi cycle. So in that diode D is on. If diode D is on, means it acts as a closed switch, means output is available across the load resistance. How much output we are getting? So V0 is equal to transformer secondary voltage, that is VAB we are getting. In the negative half cycle, same way, during negative half cycle, pi to 2 pi, a diode D is off, means diode is in off state. If diode is in off state, means obviously it acts as an open switch. Therefore, output is not available across the load resistance, means we will say that output V0 is equal to 0. Then a next point, already in the second slide we have seen that AC to DC converter is rectifier. We know that DC is nothing but a pure straight line must be there, but we are not getting. Already in the last slide we have seen a pulsating DC we are getting. So what is the next step to compensate that pulsating DC? So we have to use the rectifier to get a pure DC. Means now whatever the output or DC output we are getting, that is nothing but pulsating DC, but we require a pure DC. So for getting that pure DC, there is a requirement of the filter. So we will see half wave rectifier with a filter. By seeing the diagram, you can easily say that here a capacitor filter we are using to reduce the ripple content from the output of rectifier. Firstly, we will see which are the components that are required for the designing of half wave rectifier with capacitor filter. Again, single phase 230 volt AC supply is required. Step down transformer T1 is required. Then diode D is required. Capacitor C is required, which acts as a filter, and for checking the output we require the load resistance, that is nothing but RL is there. So here, as compared to a basic circuitry of half wave rectifier, additional components comes in the picture, that is nothing but a capacitor C, which will act as a filter and which will help to reduce the ripples from the output of the rectifier. So this is nothing but the waveform of the half wave rectifier with capacitor filter. I will tell you the steps of drawing the waveform with the capacitor filter. We know that in only positive half cycle we are getting output in HWR. So firstly you have to plot a positive half cycle by the dotted line. Means in the 0 to pi you just have to plot a dotted lines. In same way 2 pi to 3 pi session also you have to plot the dotted lines. Here segments, or we will say that uh, points are given like 0 to A to B, B to C and C to D for the sake of our understanding. So here in this particular session 0 to A and B to C consists of the diode forward bias operation. Means in the particular 0 to A section and B to C section, diode is in on state, means it is a forward biased. With the help of this forward biased diode, capacitor will get charged. Therefore 0 to A and B to C section indicates the charging of the capacitor. Okay, when diode is on, then only capacitor will get charged. Therefore 0 to A and B to C sections indicate the charging of the capacitor. After that, section A to B and C to D indicates the discharging of the capacitor. Discharging of the capacitor is nothing but diode goes into the reverse bias state. Why this diode goes in reverse bias state? Because after point A, capacitor voltage becomes greater than the instantaneous secondary voltage. Therefore, diode goes into the reverse bias. If it goes in reverse bias, it acts as open switch. Therefore, already charged capacitor C will get discharged through the load resistance, and that discharging will be shown with the help of point A to B and C to D. So overall, this is nothing but the waveform of load voltage with capacitor filter. So with the help of capacitor filter, we are able to reduce the ripple content from the output of rectifier. As we are going to increase the value of capacitor, then we are getting, or we are moving towards the pure DC supply. This is all about the waveform of half wave rectifier with capacitor filter. Again, a same operation is there with capacitor filter. So when A is positive with respect to B, diode goes in the forward bias, means it acts as a closed switch. Therefore, charging of capacitor will takes place. This charging of capacitor will be shown with the help of curves 0 to A and B to C. A next cycle, that is nothing but negative half cycle, means A is negative with respect to B, or we will say that B is positive with respect to A. At that time, diode D goes into the reverse bias. Therefore, it acts as open switch. So already charged capacitor C will get discharged through the load resistance RL, and this discharging will be shown by A to B curve and C to D. Discharging of capacitor will be shown with the help of these points. Okay, and these dotted line indicate that diode D goes into the reverse bias. Then we will see advantages and disadvantages of the half wave rectifier. So simple circuit due to simple construction. We have seen only a single phase 230 volt AC supply, then step down transformer, diode and resistance. These components are required, therefore circuitry become simple. So we will say that simple circuit due to simple construction. Number of components required are less. Due to less component requirement, it consists of the low cost. So these are the advantages of the half wave rectifier. What are the disadvantages? So already we have seen AC to DC rectifier, and when diode is in on state, then only we are getting the output. Okay, so it is a unidirectional operation. So current flows through a transformer is unidirectional. Therefore, there is a possibility of the core saturation. So we have to avoid this core saturation. We require a transformer of large size, or we will say that transformer size must be increased. The next point is ripple factor. Ripple factor or ripple content is nothing but, we know that output of rectifier must be a pure DC, but it consists of some content of AC. That is nothing but, in the output of rectifier some content of AC is there. That AC content in the output of rectifier is known as a ripple factor. This ripple factor is high, that is nothing but 1.21. If we want to talk in terms of the percentage, then it is a 121%. Next is rectification efficiency. So rectification efficiency is low, that is nothing but 40% we are getting.